Welcome to SpitFireMods. Today we're going to be covering lower heater modifications or lower heater setup. We're going to be talking about lower heaters on rework stations and what their application or part is in the profiling process, as well as how to set them up, configure them so that you're getting the most out of them. At SpitFireMods, one thing you're going to notice is our profiles are designed and they're designed around a machine configuration that is what we call flatline. In other words, we take any rework station out there, whether it has an IR bottom, a ceramic plate bottom, a hot air bottom, whatever bottom heater section it has, as well as upper heater or third zone lower heating system where it has convection upper and lower heaters. No matter what it is, we're gonna want to flatline that system to make it fit the profiling mold so that it's compatible with all other systems. In other words, our profiles are all around creating a perfect three-phase profile covering your preheat, your soak, and your flux and your rework zone, so that you have a proper preheat, which is for board heating up your board so you can avoid thermal shock to the board, a proper soak so that your flux activates properly and is most effective, and then a proper reflow. Now, as you can see, this machine has a lower heater probe that originally is mounted right here. It basically stubs out of this socket right here, this little mounting frame, and sticks out over the board about an inch out. This one is modified, but originally it basically just sticks out over the plates. And what you'll find out with foreign-made machines is that their lower probes are always tight against the plate, meaning they're just down near the plate. And what you'll see is if you have your board up here and your plate down below and your sensor down on the plates, if you set the plates to be at 180 degrees Celsius, your board will not be 180 degrees Celsius. And that's what we want to eliminate. The discrepancy from what your probe's reading and what your board is, because your lower heater is for preheating your board and bringing your board up to temperature. If it's not bringing it up to the proper temperature, or it's bringing it up to a temperature other than what it reads out, it makes it difficult to use, difficult to manage, difficult to understand, and becomes an ineffective lower heater. So today what we want to cover is the different lower heater types. And it really doesn't matter what lower heater type you have, because again, we're basing this on a flatline model. And our flatline model is like this. What it accounts for is if your board is on your rack and your probe is within 1/4 inch of under the board, meaning the board's plane is here and your probe is just there, about 1/4 inch below. It's not able to contact the board, but yet it's not far away from the board. It's in very close proximity. Now, when we say 1/4 inch, we mean 1/4 inch. It's not, you don't want to bring it closer to the board and you don't want to bring it further away. You want to bring it in that 1/4 inch. And it could be an 1/8 inch, it could be, 3/8. It could be somewhere around 1/4 inch, but we want it to be as close to 1/4 inch as possible. Everything in profiling is accuracy and repetition. So the reason it's 1/4 inch is because if you keep it at 1/4 inch on all the preheaters, typically they're a reflective type heat. Their heat isn't going in an upward direction on your lower heaters, and having it at that point gives you the most accurate reading. Having it down at the plate is very inaccurate. Having it off to the side is very inaccurate. What you're working with when you have your board on your preheater, you're going to have outside air coming across the preheater. There might be a draft in the room, but at all times your outside air is mixing with your plate temperature underneath the board. So you have your board here and your outside air is always cross-flowing under there and mixing with that, and what you have is a buffer zone. And you're going to find this on all our different stages as well. On our upper heater, our lower heater, all our different heaters have a heat source, and then they have a buffer zone, which is the area around it, and then they have external room temperature. A lot of people say, hey, if my room temperature is cold, my room temperature is high, if it's winter, if it's summer, do I need to adjust my preheater to offset for that? Now, to some degree, that's slightly true, but if you flatline your machine, that shouldn't be true. So when you're flatlining the machine, what you're trying to do is eliminate all those variances. So by keeping your board here and your probe close to the board, what do you get? And that's what we want to talk about today. What you get is you get an accurate reading. And the reason you get the accurate reading is this. If your board's here, your probe's somewhere towards the middle of the heating source, just by looking at it, you can see your probe is somewhat isolated. Like if your board is sitting on here, you can see your probe is very well tucked under there. It's very well covered. And if your board's here, your probe is extremely well covered in that heat zone and away from the buffer zone, away from the external air. If your probe can be inside that heat zone, what it's going to give you is an extremely accurate reading, a good reading, and it's going to be able to control the heat much better, because you got to remember that this probe runs these plates. If this probe thinks these plates need to create more heat, it tells them to turn on and get hotter. If it thinks they need to be cooler, it tells them to be cooler. If your probe's off here to the side, it's not going to really get a temperature of your board, and therefore it's going to inaccurately control your plates. So you have to think of it as though this probe really is what controls your board's temperature. And it does. It tells the plates how hot they need to be to make this board a temperature. Now, the first question you might think, you might think of some other things like, hey, what if I just take my probe and I tape it to the board? Or what if I take my probe and I touch the board? Or I apply it against the bottom of the board? Or put it on the top of the board? A lot of machines, they'll have them, like the AOYUE 883, they want to put it on the top of the machine. You know, this unit happens to be a Scotto HR 6000. It's pretty much the same layout as the IR 6000, except it uses a hot air instead of an IR. But it's pretty same thing. It's about an 8 to 9 inch square bottom heater. And you might think, hey, what if I touch my probe onto a subject? And that's one thing we're going to cover is what don't you do. You don't touch your probes onto the subject unless you're just monitoring the subject. And the reason is, this probe drives these plates. When you put a board on here, your board's room temperature. Your plates obviously can go a lot hotter than room temperature. By touching the probe on your board, you're telling your plates that the heat zone is room temperature. Even after the plates are heating up, it's still telling it, hey, it's still room temperature, because your board's not gonna respond. When you turn on these plates, your board doesn't jump up in temperature. It doesn't all of a sudden, it doesn't follow the plates. It follows, but it doesn't track with the plates, it tracks behind them. So when your plates are up to 100 degrees, your board is at 60. When your plates are up to 200 degrees, your board is still back there at 160. So if you're touching your board, your plates will get up to 200 and they'll just keep going. They're going to keep going and they're going to keep going until about 260. And what that's going to do is that's going to burn the heck out of your board. So we don't touch the subject because we're driving the plates from that probe. And if you touch the subject, you're always going to get an inaccurate and lower reading. Inaccurate and lower readings make the plates go hotter and a higher temperature. So an inaccurate lower reading is definitely not something you want your probe to be telling your machine to do, because when your machine's at 200, you want to tell it, hey, you're at 160, because it's going to go up 40 degrees. And that's going to create a dangerous zone for your board. Anything over 200 we consider to be dangerous. Not dangerous in that you can't do it, dangerous in the fact that at 200, when you start going past 200 for an unleaded board, you start entering what's called the maximum temperature for the components on that board. Around 220, 230, even 240, the components can start to deteriorate and internally come apart, and that's going to cause damage to your board. So we want to make sure that our plates don't repeatedly exceed 200 degrees, and if they do, they don't do it by a lot or for a long period of time. And that's another good question there, is what is the maximum that if I put my board on there and I run my preheater to 240, is that going to damage my board? If I run it to 260, is that going to damage my board? The thing to remember about maximum temperature is it's not just the temperature that they can withstand. If your board can withstand 230 degrees, it doesn't mean that it can't withstand 260. It doesn't mean that it can't withstand 300. What it means is that your board is rated for 240 degrees, meaning at that temperature it could start deteriorating. Now again, you have a follow pattern. Your board, when your board's at 200 degrees, your plates probably will be all the way up at 240. And that's the difference in distance from your plates to your board and mixing with the ambient air. When your air is coming in, your plate zone mixes with that outside air, and there's a buffer in between there that adjusts that. That's again why you want to stay within close proximity of your board, because you get a much more accurate reading in that buffer. So the question was, what can my board withstand? A board can withstand almost any amount of heat that this machine can put out, but it can only withstand dangerous temperatures for certain periods of time, and that's a ratio of the longer, the lower the temperature. So if you hit your board with 300°C hot air, you might say, hey, I can't do that because my board would be damaged. That's not true. What your board is going to do is go into a ramping period. So if you hit a 200-degree board with 300-degree air, it's going to ramp and it's going to shoot up towards 300 degrees, but it's not going to probably go all the way to 300 because your hot air dissipates over distance, but it's going to shoot in that direction, and that's where time comes in. The longer you hold it at 300, the more damage it can get. So I guess how does this actually apply to the board? The way this applies is that when you take your board all the way up to a certain temperature, say you bring your board up to 220 to melt the solder and to liquefy your solder under your GPU. The question is, do I do that to 200 and then I set my plates and everything to 200 and then I leave it there until it gets there? The answer would be no. You need to set your plates and all higher, but you need to take them into that dangerous zone for a short period of time so that when your board does catch up and get into that zone, it doesn't stay there too long. So yes, you can apply 260 degrees to your board. You could do it for 30, 40 seconds, but any longer than that, now you're running into the damaging thing. So can my board take hotter than the maximum rating? It can, but time is what dictates how long that can be. And you can experiment with that and run some clean boards that are maybe scrap boards and find out how much actually kills the board. It's probably going to be, if it was 260, it'd probably be about 60 seconds to 120 seconds, depending on what nozzle or what component you were using to heat up the board. Anyway, so back to lower boards. Your lower board area needs to be accurate. It needs to run at the right temperature. Ideally, if your board is here and your probe's a 1/4 inch below, setting your preheater system to 180 should make your board 180. And what you'll find that when you have your board there and a 1/4 inch below it is your probe, and it's within that heating zone, typically setting that probe to 180, being just below the board, will actually make your board pretty much hit that temperature. So 1/4 inch below the board is what's required on all machines. Now you might say this machine, which is an HR6000, or if it was a Hanton 390 or a 490, would have had a probe mounted right against the plates. And most foreign machines would. So you might say, well, why do they do that, or what does that do? And you'll see that a lot of their profiles require you to preheat at 160 with the probe right on the plate. What you can find out is that doesn't do much of anything. And the big thing is it's just wrong. It's not adequate. It doesn't preheat the board sufficiently, and it will damage your board. So what you want to do is you want to modify that. So any probe that is tight against the plates, you need to get rid of that and make it more usable. And again, we speak strictly on large size BGA boards. So we're not talking about cell phones. We're not talking about small boards. You may have other applications, video cards. You may have small boards that don't fit this mold. So at SpitFireMods, we focus and specialize strictly in large size boards. Anything about 8-9 inches or bigger. So when we talk, we're talking about large size boards. We're not giving, this may not apply to a small board should you do a small board. If you had a small board on here that barely covered this heat zone, you may actually not want your probe up against the board. You may actually want it off somewhere else. I personally would probably put it up against the board, but you may be able to get away with having it in a different area. Now, so we covered types of heaters. Now we're going to cover specifically modding it. The first thing you want to do with if your probe is down here, like your probe is sticking out just here, what you want to do is move that, and you want to elevate it up under the board. So the best way to do it is to extend that probe up. So you're going to want to detach it from there. Look in the bottom of your unit, open your bottom cover, and find out where it's secured. Make sure you loosen it up so you get enough slack, and then pull it up here. Stretch it out to a nice length where it's out in the middle of the board, and then it'll be very flimsy. It'll just basically be laying there, so you want to reinforce it. The best thing to reinforce it with is rigid copper wiring. This piece of copper wiring is wrapped around the probe and then secured to the nut that it was originally attached to. So what we're doing is we're taking the probe out, and then we're replacing the probe with a secure piece, something to secure it with, and then we're putting that in, and then we're using that, and we're just winding it around our probe. So now we have a flexible probe. I can stick that probe up, I can stick the probe down. I can move it where I need it, which is a nice little L pattern so that it's coming up to the board, and then when I put my board on there, it's in the right spot. And if you need schematics or more details on opening your machine and getting in there and doing that, we can supply that. We actually have that for the IR6000s and the other units that you'll find you do want to modify. So this pretty much is all we're covering today on our lower heater modification or setup video. So what we wanted to cover was the fact that you want to get your board within the zone. Your zone is your footprint of your heater, and the more in the middle of that and then the center of that is where you want to be. So that's all we're going to cover here. This video is a set of a series, so you're going to have other videos on what to do after this video and before this video. So thank you for watching, and that's the end of this video. Thanks.